This is AP Calculus 5.1 through 5.4 Review, problem number 5. So we are looking at the velocity function in meters per second as being v of t equals t squared plus 3t minus 10 on the interval from 1 to 6 seconds for a particle moving along a line. So they want us to do two different calculations. They want us to find the net displacement of the particle and the total distance traveled by the particle. So I want to remind you that these two things are not the same. The net displacement is just where you start to where you finish, right? The integral of that distance. So for us, the net displacement is just going to be the calculation of the integral from 1 to 6 of t cubed plus 3t, t squared plus 3t minus 10 dt. Okay, and that's just going to give us our net displacement, the difference between where we started and where we ended, basically. And again, we can do this calculation just by integrating our function and using the fundamental theorem of calculus. So the integral of t squared would be t cubed. The integral of 3t would be t squared. We would still have the 3, but we'd have to divide by 2, so that would become 3/2 t squared. And then negative 10 would become negative 10t. And again, this is going to be evaluated from 1 to 6. So then I'm going to go ahead and I'm going to plug in 6 and I'm going to plug in 1. So then I get 6 cubed plus 3/2 times 6 squared minus 10 times 6 minus, and then I'm going to plug in 1 cubed plus 3/2 times 1 squared minus 10 times 1. And then I'm going to grab my calculator and I am going to type this in. I can do a little bit of the math in my head, but basically when you grab your calculator and you type all this in, you should get that the net displacement of the particle is equal to 74.167 meters. Okay. So now in part B, they want us to find the total distance traveled by the particle. This is slightly more work because in order to calculate this using integrals, we need to know when the particle is moving forward and when the particle is moving backward. And in order to figure that out, we need to know when our particle is at rest, okay? And so in order to find that, we need to find when our particle is at rest, okay? And our particle is at rest when the velocity of the particle is 0. So if I take my velocity function and I set it equal to 0, then I have 0 is equal to t squared plus 3t minus 10. And this is an easy factoring problem, right? Two numbers that multiply to make negative 10, but add to make positive 3 are going to be t plus 5, t minus 2, okay, which is going to give us t is equal to negative 5 and t is equal to positive 2. Well, obviously, if t is representing time in seconds, then the t equals negative 5 doesn't make any sense, and only the t equals positive 2 makes sense. So we know that our particle is moving in one direction from 1 to 2, and then it stops, and then it turns around, and then it moves in a different direction from 2 to 6. And if you want to know which direction it's moving in, then just plug a number in that interval. So for example, if I want to know if it's moving forward or backwards from 1 to 2, what do I get for my velocity if I plug 1 into my velocity function? Well, 1 squared is 1, plus 3 times 1 is 3, so 1 plus 3 is 4, but 4 minus 10 gives me a velocity of negative 6 at t equals 1 second. So that tells me that if my velocity is negative at 1 second, then the particle is moving backward. Okay, so right here from 1 to 2, I can say that the particle is moving backward. Which means obviously then over here from 2 to 6 seconds, the particle is moving forward. And we care about this because when we calculate our total distance traveled by the particle, we're going to do it with two integrals. We're going to do the integral from 1 to 2, and we're going to do the integral from 2 to 6, because we know that the integral from 1 to 2 is going to come out negative, so we'll have to take the opposite of that so that the absolute value of our distances are positive when we're adding them together, and we're getting the total distance traveled by the particle. Okay, so if I set this up as an integration problem, as I just said, since my particle is moving backwards on the integral from -1 to 2, then I'm going to have negative the integral from 1 to 2 of t squared plus 3t minus 10 dt, plus, then my particle is moving forward from 2 to 6, but again, same function, t squared plus 3t minus 10 dt. And then I can just do these calculations. Well, I already did the integration in part A, so I already know that it's t cubed plus 3/2 t squared minus 10t. So I can go ahead and I can plug those numbers in. And when I do that, again, I'm going to have this negative out in front here. And again, it's going to be, for the first problem, it is going to be 2 cubed plus 3/2 times 2 squared minus 10 times 2 minus 1 cubed plus 3/2 times 1 squared minus 10 times 1, okay? And that negative sign in the front is for all of that, right? So when I do that calculation, I end up with negative and then negative 3.1666 repeating, okay? But then plus over here, now I have to evaluate the integral from 2 to 6. So when I do that, that is going to be 6 cubed plus 3/2 times 6 squared minus 10 times 6 minus, and then I'm plugging in 2. So 2 cubed plus 3/2 times 2 squared minus 10 times 2. Okay. And when I do the math there, I end up with 77. Sorry, my iPad seems to be disappearing on me. I'm not sure why it's doing that. Holy cow. That's weird. It's 77.3 repeating. Okay, 77.333, so on and so forth. So then again, right here, when I take the minus a negative, chop, chop, right? This is the absolute value part, or the part that makes both of my distances positive. It's why I have to account for the negative or the backward movement separate from the forward movement. But when I add these two together, I get a total distance traveled by my particle of about 80.500 meters. So make sure that you understand the difference between if somebody is asking you for net displacement versus if someone is asking you for total distance traveled.